So welcome back. In previous lecture we discussed about the transform faults, and the most notorious and dangerous transform fault other than the mid-oceanic ridges, which are evident on the Earth's surface, is your North Anatolian fault in Turkey and San Andreas fault system in California. So these are the two major fault system. Of course, there is one more, which is median tectonic line that exists in Japan, and other one, it's not so large as these two systems are, but there also exists a major transform fault system in Himalayas, that is in Karakoram fault system. And now that because of the plate tectonic movements and the ongoing active tectonisms, we have these 2 points, which are the tallest and the deepest one on the Earth's surface, that is Mount Everest, almost like 8,850 meters, and the Mariana Trench, deepest one, 11,035 meters. And other than that, what we have is the Pacific Ring of Fire, as we discussed in the one of the lecture, that these are all along this boundary. We see the alignment of the active volcanoes, and then we have the mid-oceanic ridges, and the longest one is your mid-Atlantic ridge, that is the spreading centers, and the mountain building activity which we see is the alpine Himalayan chain. So configuration of the tectonic plates, if we take in total, then we have, like at various locations, with respect to the tectonic boundaries, we have divergent plate boundary, we have convergent plate boundaries, and we have transform plate boundaries. So as I was mentioning, that we have this blue arrows which are showing the direction opposite to one another is your convergent plate boundaries, and with the red arrows are been shown as the spreading centers is the divergent plate boundary, and in between we have the transform plate boundaries, and the major one which I was talking about is the along the Northern American plate and the Pacific plate, and in some locations we have over here, as well as I was just mentioning about that we have in India also, that is the along the subduction zone. So if you come towards the north of the Sumatra Andaman subduction zone, the Andaman region is showing the boundary which is almost like the strike slip one, whereas here we have collision, but there is one fault system which exists, is showing the right lateral strike slip. Three type of boundaries we have: divergent, convergent, and transform. This cartoon shows the location of different plate boundaries on the Earth's surface. So the detailed one is your divergent plate boundary, where we have the magma which is coming up and new crust is continuously forming along this one, and in between what we have is the transform faults. So these are all transform faults, and this is your divergent plate boundary. So what the landforms which will be associated with this type of plate boundaries, that is the divergent plate boundary, will have rifting, where the two plates are moving away from one another. We will also see the volcanoes, and along with that the associated hazard will be your earthquakes. Then coming to another one, we have the rift valleys, as we have seen the example of the African plate, and we also discussed in brief the East African Rift Valley. So, we will see rift valleys, volcanoes, as well as associated earthquakes in such locations. So, the previous one was your oceanic plate separation, the mid-oceanic ridges, and the best example is mid-Atlantic, and this one is continental plate separation. Both are categorized as divergent plate boundaries. Then the prominent feature which will develop between the two plates, that is mainly during the convergent boundaries, is your trench, and one of the best example that exists between the Pacific plate and the Philippine plate is your Mariana Trench, and the depth of this is almost around 11,035 meters. So, here again we will see the formation between the oceanic convergence. We will see the formation of oceanic trenches, volcanic island arc on the overriding plate, and we experience here again the deep earthquake. Along with that, we will also experience intermediate and shallow earthquakes. Then another part of the convergent plate boundary, where you are having the oceanic and continental convergence. So, best example which has been given is the Chilean type of trench. We have the Nazca plate subducting below the South American plate. So, on the land portion, that is the continental portion, again we see the formation of volcanoes, and the best example between this two plates is the Peru-Chile trench, and on the surface of the overriding plate we have Andes Mountain. So, again we will come across the volcanic chain, folded mountains, and deep earthquakes. Along with this, as I told in the previous one, we will also have shallow and intermediate earthquakes, and these deep earthquakes are with respect to the depth at which they are occurring. Then coming to the third one is the convergent plate boundary, is the continental convergence. The best example is Himalayas, where the Australian plate or the Indian plate is subducting below the Eurasian plate. But at present, what we see is just the collision between these two. But the plate which subducted initially, this boundary remains, hence we also term this as a convergent plate boundary. So, landforms here, what we see is mostly the crust thickening, folded mountains, and shallow earthquakes mostly, because no plate is getting below this portion. So, we have mostly the shallow earthquake in this region. So, these are the important points: the thickening of the crust here, and then what we are getting is the rising up of the topography, that is the mountain chains, folded mountain chains, and the best example is your Himalaya. Then comes another one, is the third one is the transform faults. So, the best example of transform fault is the mid-Atlantic ridge and the mid-oceanic ridges, and in between you have the transform faults. So, which behaves like there will be movement in a lateral fashion, and of course the earthquakes will be all shallow earthquakes here. So this is related to the mid-oceanic ridges in the ocean part, but on the land you have continental transform fault boundaries, and the best example which we were talking about is one of the notorious fault or the dangerous fault is the San Andreas fault system, which is formed because of the deformation between the Pacific plate and the North American plate. So, this plate is moving in this direction shown by this arrow, and this portion of the plate on the left hand side of the plate boundary is moving away from us. So lateral transform faults as well as earthquakes. So here also again we will see mostly the shallow earthquakes. So this is an overall configuration of the plate boundaries, and the important part which we should remember here is that depending on the different type of plate boundaries that exist between the respective plate, different type of earthquakes in terms of the depth will occur, and the hazard which has been related to such plate boundaries will vary from place to place depending on the configuration of the plates. That is the pattern of the plate boundaries that exist on the Earth's surface. So we discussed in the beginning that we have the all well aligned occurrence of the earthquakes along the plate boundary. Along with that, we have also the alignment of the orientation of the or distribution, we could say that would be better, that distribution of the volcanoes along the plate boundaries wherever we are having the convergent plate boundaries where the oceanic plate is subducting below the continental plate. Now this all plate boundaries marked in yellow are been classified as passive continental margins. Includes those facing the Atlantic, Indian and Arctic oceans, are characterized by very few earthquakes, are considered inherently stable. So these are the regions, of course they are the spreading centers here, but they are considered to be an passive continental margins, whereas the marked with the red one, all are active continental margins, includes those facing Pacific Ocean over here and others extending western side of the Pacific Ocean through Indonesia, China, Central Asia and Middle East. So these are all active continental margins which are responsible which are the areas which have triggered large and mega earthquakes in past and even in the recent time. So as I was talking about that the our worry basically is that along with this plate boundaries, what different type of earthquakes with respect to depth will occur, because this will be associated with what type of hazard we are going to experience. So subduction zones basically are of two types which have been classified in 1979 by Uda and Kanamori. They proposed two N members type of subduction zone. So one is the Chilean type subduction zone. So this is what we were talking about in one of the slide of convergent plate boundary, that is between the oceanic plate and the continental plate, that is Peru-Chile subduction plate boundary. So they have been classified as an Chilean type subduction zone. Now in this what has been shown here is that you have an older oceanic crust, okay, with a shallow depth. So there are few important points which we should consider when we are classifying the types of subduction zones. So we have a shallow subducting plate which is going down with respect to the overriding plate here, and the features which we will see on the surface is the back arc, compression and uplift on the overriding plate. In front of that we will see and the formation of the sediment succession resulting into the formation of accretion prism, and we will have shallow trench. So in the Chilean type we will see the formation of shallow trench. The other one is the Mariana Trench, which is between the Philippine and the Pacific plate. And since there is the the friction or the drag has been confined to a very large area, we will also see a formation of bulge or the deformation which will be experienced by the under thrusting plate. And such plates, which is we are classifying as in Chilean subduction zones, are younger, thin, hot and buoyant lithospheric subduction will occur. So we have Chilean type subduction. So we have young buoyant lithosphere which resist subduction and result in a shallow dipping seismic zone. So we'll have a very shallow dipping seismic zone because the contact between the overriding plate and the under thrusting plate or the subducting plate will be in a very shallow nature, and the area of contact will also be larger as compared to the other if you are having the sharp dipping subducting plate. Shallow trenches, great thrust earthquakes. So very large magnitude earthquakes will be experienced in this type of region, and the best example of, because this is the 1960 Chile earthquake, magnitude 9.5. So one of the largest recorded, or we can say that this is the only largest recorded earthquake on Earth till date. Now coming to another one is the Mariana type subduction zone. So here the major difference is that there we were having the younger and thinner oceanic plate, but here we are having the older, thicker and denser, and those type of the plates that is in Chilean type is the lighter one as compared to this. Now the dip of this plate, that is the subducting plate, is steep, and because the contact between the overriding plate and the subducting plate is not much as what we were looking at in the shallow type, because in the shallow one what we were looking is that we are having a very wide area which has been covered. Okay, so shallow subducting plate will have or shallow dipping subducting plate will result into the shallow focused earthquakes, but in this case no large earthquake or no large magnitude thrust earthquake will be experienced. Whereas other part is, since the plate is steeply dipping, so this will result into the formation of deep trenches, and the best example is the Mariana Trench. (11,035 meters deep). And the overriding plate will experience extension because of the pull of this subducting plate. Okay. So Mariana Trench or the Mariana type subduction zones, usually what we see as the subducts old dense lithosphere which readily sinks because of the older and thicker one. Okay, or maybe you can say the thicker as well as denser, so it will subduct or has been pulled down in such a way that it will result into the steep dip. Mariana type subduction zone are characterized by steep dipping seismic zone, deep trench, back arc extension on the overriding plate, okay, and absence of great thrust faults. Okay. So this type of areas will not trigger large or great magnitude earthquakes. So Chilean or the convergence related compressional mode and the Marianas or convergence related extensional mode of the subduction zone. This is basically what we are looking at is the convergent plate boundaries. So basic difference you should remember, and this is everything is related to the seismic zone. Okay. So we'll have the absence of the great earthquake, whereas in that the other one, that is Chilean one, we will have the presence of the greater thrust faults and the earthquakes also. And the best example of the Chilean type subduction zone, that is in terms of the earthquake, is your 1960 Chilean earthquake with magnitude 9.5. Now this can be further explained with the help of this Wadati-Benioff zone. Okay. Basically, if you are having if you are talking about the different type of earthquake, that is in terms of the focus of the earthquakes, how deep they are occurring along the plate boundary. Okay. So on the surface plate boundary, as well as with the portion which is subducting below, will also result into the earthquakes. So at any subduction zone, usually what happens is the cold oceanic lithosphere is pushed down into the mantle, where two plates converge at an oceanic trench. So this portion is your oceanic trench, and this is the convergence which is taking place. Now because the subducting lithosphere is cold, it remains brittle in nature as it descends, and this fractures under the compressional stresses, and this process will be responsible for triggering earthquakes. And so during fracturing, because when they fracture, they will trigger earthquakes, and this zone is defined as a zone of earthquakes with increasing focal depth beneath the overriding plate. So increasing focal depth beneath the overriding plate. This zone of earthquake was been termed as, or are termed as, Wadati-Benioff zone. Focal depths of earthquakes in Benioff zone can reach down up to 700 kilometers. So these are the deep earthquakes which are occurring. So you can imagine the subducting plate which is going down can trigger earthquake up to the depth of, or at least up to the depth of 700 kilometers. So this is the same diagram which has been explaining that how the subducting plate will host the different type of earthquakes. So these are the deeper earthquakes which are going below 600 and around 700 kilometers, and then we will have shallow earthquakes which can range less than even 100 kilometers. So these earthquakes will be definitely dangerous. Now coming to the Indian part, as we have discussed, that we have almost the mighty Himalaya, which is stretching from east to west over 2,900 kilometers along this line here, and this is one of the prominent plate boundary, and the example which we have is the Himalayan range. Now this portion which I am trying to explain is important for us in terms of the deformation pattern, because this will like tell us that which area will be more active and which area is less active compared to the rest of the plate. Okay. So the Indian plate, if you consider that the whole plate is colliding with the Eurasian plate, so the boundary, that is the head-on collision which is occurring along this one, is having more deformation as compared to the rest of the plate. So you cannot say that the rest of the plate is not under the compression, but whole plate is under compression, but the deformation, the rate of deformation will vary from this region to this region. So based on the GPS measurements, keeping this as a fixed point, and this is moving towards in the north-northeast direction, the direction of the Indian plate motion, the point from Bangalore towards the Eurasian plate, it is around 50 millimeter, and between this point and right up to the Himalayan front, it is consuming around 5 millimeter. So still 45 is left out from this one. Okay. So across Himalaya, or the deformation which has been consumed is around 20 to 21 millimeter. So this portion is more consuming more of the total deformation between these two. That is the convergence rate. Okay. Hence, this will be the area of the hosting large amount of seismicity or higher seismicity in the number of earthquakes as compared to this one, because the deformation is larger here and more amount of strain has been developing. So this area will become the area of high strain, and this region is the area of low strain. So the recurrence between the two earthquakes will be larger, whereas the recurrence between the two earthquakes will be lesser here, because the deformation is higher as compared to this region. So as I told, that whole plate is flexuring. It is not the only the portion which is in contact with at the contact between the Indian plate and the Eurasian plate. Only that boundary is active, but the whole plate in a sense is under deformation, and this is one of the reason why we experience the earthquakes like in Latur, in Bhuj, in Jabalpur, and so on. So slowly we will move towards the part of the paleoseismology, but before we get into that, the most important for us is that what is the pattern of distribution of earthquakes in this region. That is the important one. For example, if we look at the Himalayan arc here, we have some that in terms of the historical records, some information is available which are been put, we have put here, like the historic earthquake of 25 AD and 1869, 1842, and so on, 1885. So far whatever the records are available with us in historical chronicles, we have tried to incorporate that, and the best example which we have, or the written records which are available, was from the written records of 20th century. That is the three major earthquakes which were been triggered in Himalayas were 1905 with the magnitude of 7.8, then we had 1916, and then another one major one was 1934, and over somewhere here, that is in the eastern side, that is in 1950 Upper Assam earthquake. So the distribution of these faults are important, and that what we are going to talk about, and what type of earthquakes and how many earthquakes were been experienced in the past. Of course, as we have been talking right from the beginning, that we will go up to 10,000 years. For us, it is important for the paleoseismic records. So we'll try to see that in the past 10,000 years, how many earthquakes have been triggered along the individual fault, and which fault is more active with respect to the another one. Okay, that is another important part of this study. Okay, so I'll stop here, and we will continue in the next lecture. Thank you so much.